Okay, this video is going to cover questions 16 to 19 in the midterm review exercises. So here we're going to consider the random variable x with the cumulative density function, capital F of x, given by this monstrosity, right? Now remember, the cumulative distribution function, capital F of x, is telling us the probability that x is less than or equal to that particular value, little x. And so, if you recall, when we're looking at the cumulative distribution function, the places that we see jumps in the distribution, it's a step function, and where the steps are, that indicates what the possible values are that x can actually take on. That's where the positive probability is. So right away I know that the possible values, so I'm going to be first of all finding the probability mass function. So the possible values that x can take here are going to be -1, 0, 1, and 10. Now, the way that I figure out the probability of each of those values is by looking to see how large a step there is at that value. So we can see that at -1, the step goes from 0 to 0.15. So the size of that step is the probability that x takes on the value -1. This would be 0.15. Now at 0 here, we step from 0.15 up to 0.45. So we take 0.45 minus 0.15, it gives us 0.30 is the probability that x equals exactly 0. At 1, we have a jump from 0.45 to 0.65. The size of that jump is 0.20, and that's the probability that x equals 1. And then finally at 10, we go from 0.65 to 1, so I subtract 0.65 from 1, and I get 0.35 as my probability that x equals 10. And just remember, it's always a good idea to double check that all these probabilities sum to 1. They have to do that in a probability mass function, and in fact they do. So question 17 now is asking me to find the expected value of, the mean of x, which is the same as the expected value. So the mean, which is the expected value of x. Once again, I'm just going to sum over all of the values of x times f of x. In this case, that's going to be -1 times 0.15 plus 0 times 0.30 plus 1 times 0.20 plus 10 times 0.35, and that whole thing is going to come out to 3.55, and that is the mean of the random variable x. Next piece I'm looking for is the standard deviation of x. Again, this is similar to what we did before. The standard deviation sigma is the square root of the variance of x, and the variance of x is the expected value of x squared minus the mean squared. We have the mean, so we're going to find the expected value of x squared. The expected value of x squared, I'm going to sum over all of the possible values of x squared times f of x, and so I'll take my -1 squared times 0.15 plus 0 squared times 0.30 plus 1 squared times 0.20 plus 10 squared times 0.35, and that gives me the expected value of x squared equal to 35.35. Now my standard deviation is going to be the square root of the expected value of x squared, 35.35, minus the mean, 3.55, squared. And that whole thing, once I put it in the calculator, will come out to 4.7694 once it's rounded to 4 decimal places. Okay, so the last part of this, we're looking to calculate the expected value of 2 plus x to the x power. Now remember, when we're calculating an expected value of a function of x, u is our function of x, the way that we do it is we sum over all of the possible values of x, the function evaluated for that value, times the probability that x takes on that value. So in this case, I'm going to be summing for all the values that x can take. I'm going to be looking at 2 plus x raised to the x power times f of x. Okay, so using my probability mass function, 2 minus 1 to the minus 1 power times f of x. F of x there is 0.15 plus 2 plus 1 to the 1 power times the probability that x equals 1, 0.30, plus possible value of 1, so 2 plus 1 to the 2 plus, this should be 2 plus 0 to the 0 times 0.3. And we should have 2 plus 1 to the 1 times the probability that x equals 1, which is 0.20. I meant to substitute the 0 in here, and I somehow put the 1 in. So it should be the 0. I hadn't done that yet, and that's the probability of 0. And then I'm going to keep going. I have 2 plus, my last value is 10 to the x 10 power times the probability that x equals 10 is 0.35. Alright, so let me put this all in the calculator. So I have 2 minus 1 to the minus 1 power times 0.15 plus 2 to the 0 power times 0.30 plus 2 plus 1 to the 1 power times 0.2 times 0.2 plus 2 plus 10 to the 10th power times 0.35. Okay. So that gives me 5987.02 if I round to 2 decimal places. Let me just double check myself one time. Yep. Okay. Just wanted to double check it before I had a bunch of mistakes. Okay, there we go. So that's how we found the expected value of a function of x. In this case, the function was 2 plus x to the x power, but the same principle would apply to any function of x. All right. Thank you.